Welcome to Intelligence Gateway.
Akamai Network Engineering, Lecture 02. Network Design and Planning. Understanding network requirements and goals. Network design principles and best practices. IP addressing and subnetting. Network capacity planning and scalability. Network design and planning tools. Network security considerations. Understanding network requirements and goals. Understanding network requirements and goals is a critical aspect of network design. It involves identifying the needs of the organization, determining the scope of the network, and defining the goals that the network is expected to achieve. By doing so, you can ensure that your network is designed to meet the specific needs of your organization. For example, if your organization requires high-speed data transfer between different locations, then you need to design a network with sufficient bandwidth and low latency. On the other hand, if your organization deals with sensitive data, then you need to focus on security and implement measures such as encryption and access control. Network design principles and best practices. When it comes to network design, there are several key principles and best practices that can help ensure a reliable and efficient network. One important principle is to design for scalability, which means planning for future growth and changes in the network. This can involve using modular hardware and software components that can be easily upgraded or expanded as needed. Another best practice is to design for redundancy, which means having backup systems and components in place to prevent downtime in case of failures or outages. This can involve using redundant power supplies, network connections, and storage devices, as well as implementing failover mechanisms to automatically switch to backup systems when necessary. IP addressing and subnetting. IP addressing is a fundamental concept in networking that enables devices to communicate with each other over the internet. Every device connected to the internet has a unique IP address, which consists of a series of numbers separated by dots. There are two types of IP addresses, IPv4 and IPv6. IPv4 addresses are 32-bit numbers, while IPv6 addresses are 1 to 8-bit numbers, allowing for a much larger number of possible addresses. Subnetting is the process of dividing a network into smaller subnetworks or subnets to improve efficiency and security. Subnetting allows network administrators to assign different IP addresses to different devices based on their location or function. For example, all devices in a particular department can be assigned IP addresses within the same subnet, making it easier to manage and troubleshoot network issues. Subnetting also helps to improve security by isolating different parts of the network from each other. Network capacity planning and scalability. Network capacity planning and scalability are critical components of network design. Failure to properly plan for future growth can result in network congestion, slow performance, and even downtime. By contrast, a well-planned and scalable network can accommodate growth and changes without sacrificing performance or reliability. One practical example of the benefits of proper planning is the ability to add new users or devices to the network without disrupting existing operations. With a scalable network, administrators can easily add new switches, routers, or other equipment as needed without having to re-architect the entire network. This not only saves time and money, but also ensures that the network remains stable and reliable. Network design and planning tools. There are several tools and software available for network design and planning that can help you create a reliable and efficient network. One of the most popular tools is Cisco Packet Tracer, which allows you to simulate network configurations and test them before implementation. Another useful tool is SolarWinds Network Configuration Manager, which automates network configuration tasks and provides real-time monitoring and alerts. For larger networks, you may want to consider using network management software such as Nagios, which provides comprehensive monitoring and alerting capabilities. Other tools that can help with network design and planning include Wireshark, a network protocol analyzer, and GNS3, a network emulator that allows you to run virtual networks on your computer. Network security considerations. Network security is a critical consideration in network design and planning. A secure network protects sensitive data, prevents unauthorized access, and ensures that the network operates reliably and efficiently. There are several practical tips that can help you secure your network against common threats. One important step is to implement strong authentication and access control measures. This includes using strong passwords, limiting user access based on their roles, and implementing multi-factor authentication. Additionally, it's important to keep software and firmware up to date with the latest security patches and updates. Finally, regular monitoring and logging of network activity can help identify potential security issues before they become major problems.
Thanks for watching. For more information, like, comment, and subscribe our channel.